So we're here again at High End Munich. This time we're with Audio Group Denmark and the very, very famous Michael Børresen. We're going to talk about their new products. And first of all, we're going to talk about the new M2, which is the intermediate speaker in the M range. And you tell us a little bit about it.
Our highest range is the M range. So we have a monitor, we have a floor stander, which turned out to be quite a big floor stander. So initially I didn't want to make the M2, but we had a lot of requests from our clients, especially in the US, where we sold quite a number of the M1s.
Is that a price thing?
Yeah, I think it's a price thing. It's also a size thing. So some may have a room that's suitable for a monitor and a little larger speaker, but not necessarily a big floor stander like the M3 is. So Tyler kept bugging me for a while, and I sorted out how to make the design and how to fit the drivers in a more moderate space than the M3.
So is it the same tech?
It is the same tech. It's a zirconium basket. It's a silver non-ferrous. It's a magnet system without any iron, but with pole rings of silver. So it is the best of the best we can do in terms of drivers and terms of the tech we put in. So it is. It came out for me as an outstandingly good product. Sound very full range, very full-bodied, and for sure with the resolution and the speed and the driver, that is the best we can do.
And how would you describe the sound of these speakers, the M range?
I think as a hi-fi manufacturer, we have only one job, that is to get out of the way. So we cannot afford to put any tweaks to the tonal balance, any addition to the signature, because we want to bring Leonard Cohen alive, and we cannot do that if we put our flavor on that.
Okay. So do you go for a flat frequency response?
No. Frequency responses in speakers cannot really be flat. Okay. The reason is you need a multi-way speaker. There's very few speakers that only have one membrane for the full range, frequency range, and whenever you have an overlap from a slightly heavier mid-range to a very light tweeter, even if they play the same in a little different way. If you try to sum up, so that area is flat, but consists of two different drivers' way of playing that frequency range, you will hear it as a resonance standing out. Okay. So essentially in that area, you need a small dip in the frequency response to make it sound flat, but not really flat. Not necessarily measure flat. And you saw this, with the old Rogers LS3A, where they make the BBC curve, where the tweeter falls off and the mid-range, they could not really reach each other because the drivers were the way the drivers were. But that sounded incredibly natural. So something sounds natural does not measure flat.
So you mentioned the drivers and the zirconium and all the rest of it, and I remember visiting you guys, and your enemy is aluminium.
Yeah, I don't think our enemy is aluminium per se, but every time we make something out of aluminium, we encounter a resonance in the material that we do not necessarily like. Okay. Whereas all the materials that our body readily accepts, that being stainless steel, that being titanium, that being zirconium, sort of like having more natural...
From a surgical point of view.
From a surgical point of view, also tend to sound more natural. Okay. And especially when it comes to a basket for a speaker, when you have the magnet fastened here and the membrane here, when the membrane moves off, it puts the magnets back and vice versa. So it stands there in elasticity, ringing all the time with the tone it has. So even if you don't measure it, that tone of that basket is always present in the sound.
And the membranes, what are they made of?
The membranes are a sandwich of actually 4 layers. It's outside is a titanium skin, which has been treated in a particle accelerator with all the fancy layers.
That's done at the university?
Yeah, it's the Technological Institute, it's called in Denmark. It's and then it has a carbon layer made of spread toe. And the advantage of spread toe is that it's a very flat weave. Okay. And another advantage is that it's stiff in 2 directions and quite soft in the other directions.
And that means that if you look at from a rotational point of view, your membrane is stiff and very stiff. So but it varies enormously in stiffnesses. So that the standing wave resonance you can have, figure a string fixed in 2 points, that will ring. But if the tension is different, it will ring with different tones.
Okay.
And that's what the different stiffnesses does, is actually do the same. So it's virtually impossible for a membrane like that to have a very predominant first order resonance. And it's almost annihilated. And that makes the tone far less. The stiff material is always a little bit dangerous because it rings with a very high Q. So it rings with an enormous bell-like sound. If you take a pure membrane from metal or aluminium or whatever, it has a ringing to it. Yeah. These membranes do not. They are stiff but very, very damped at the same time.
So the cabinet is a really interesting design. Why is it that shape? Why have you got the indents on the side? And
figure the old days, you have these metal roofs. If you look at the metal roof, they are always profiled. Mm-hmm. The reason they're profiled is that you get a stiffness. So if you add this profiling to the cabinet, you get an enormous stiffness to the cabinet. So it's a good way to shape in a build stability to the cabinet.
What's the material that you make the cabinet?
It's wood fibers.
It's wood fibers.
Yeah, it is wood fibers.
So how much of the performance of the top model do you think the M2 brings?
I like this. I have a pair of these at home because I like the tonality and what it brings out. It seems like to me they're a little more intimate.
Okay.
But maybe a little less dynamic than the top ones we have.
Would you say they're the sweet spot in the M range?
Yeah, I love this speaker.
Okay.
I really do.
I really do. We talk a lot. We do talk quite a lot, and you can tell that you're really enthused by this speaker.
Yeah. I think it's been such a great process, and it's been such a great result. It's you know, when you set out to make something, you have hopes, and sometimes your hopes turns into disappointments. But this turned into love instead. So
so these are making their European debut at Munich?
Yeah, this is the first time we take them out on the show.
And what's the feedback been like?
Oh, amazing, yeah.
Cool.
It's first of all, Munich is a good venue, and we get to see all our dealers, and we get to see many private people as well.
Yeah.
So it's a very, very, very nice venue to be in and to stay in.
So going away from your speakers, and we're going to go and look at a few more products in a short while. What do you think to the move to Vienna from Munich? A good thing, a bad thing?
I think for us, because it's the same organizers.
Yeah.
So it will be we can have the same as we have here, and we've been working with these sound cabins for a number of years, and we always manage to get nice results. So I don't fear that. What I do fear a little bit is that it becomes a little more difficult to get to, so all our international clients may stay away because it's too complicated. For me, going to Vienna, which is a very nice town,
absolutely
nice city, so for me it will be love for sure.
You're the second person I've spoke to that's talked about the logistics of getting to the venue, but like you, I think the city's beautiful. The venue is excellent.
Yeah.
So shall we move on to the next product?
Yeah, let's do that. Let's have a
debut?
talk. Yeah, let's have a talk about the phono stage.
Cool. So the next product we're going to look at with Michael is the new R880 phono stage, and we've just been having a little bit of a chat. And I assumed this was just an optical stage that Aki-san does from DS Audio. And I don't know if you know DS Audio, but they do an optical cartridge, and he's basically made it open source. So anybody can make an optical phono stage. But you've not just put an optical phono stage, you put...
No, I think that this is our top tier product. So we actually made it so it's 4 phono stages in one box. So it has 2 moving coils, because that's still the predominant high-end cartridge. But it also has a moving magnet.
And is that so people can have 2 arms on their turntable?
Yeah, whatever they want. Okay. We see often, that those that are really into phono has multiple rigs, several turntables and stuff like that. So it's nice to be able to collect everything into a multi-input source. phono stage.
So,
So it has two MCs,
Okay.
which are fully adjustable. You can adjust loading from 50 ohms to 5 kilo ohms,
okay,
and you can do it on the fly. You can sit there and do it on a remote control.
okay,
And you can also adjust the gain on the MC from 57 dB to 75 dB. So you have an option of 3 different gain settings, meaning that you can go from a fairly high output, like a Goldfinger or something like that, and go to a very, very low, a Frog or whatever, a high-end cartridge you have that has very low output. And with MCs, it's like the lower output you make, the less weight you have to move. So in theory, you can get higher resolution.
okay.
And you also get less thermal noise from the cartridge because the ohmic impedance is less, so it creates less noise, but obviously also less output because there's fewer winding in the magnet system to create the voltage output.
So it's a very high-end product. It's obviously a high-end product, and moving magnets are seen as very much the poor relation to moving coils. So why have you included a moving magnet?
Yeah, but if you look at some of the very good cartridges, like a Deca London,
Of course,
you can never omit that. That is still a high-end cartridge.
Mm-hmm.
And if they were to make that cartridge today with the needles you can get, with the diamonds you can get, the fine line and whatever line contact diamonds you can have, even Shibata needles are better today than they used to be, micro rich.
Yeah.
So if you take that and find and have it retipped, you have a very high-end cartridge, but it has a high output, so it cannot go into any MC input. So that's why we put an MM. We have also some mono cartridges with fairly high output can go into that. So we have the
Something
option
for everyone.
Yeah,
in there.
exactly.
So-
That is also, the MM is also fully adjustable, both in gain, but also in capacitive loading and resistance.
Which is unusual. Most people
But you need it. You need to tailor the input to the cartridge you're using always.
And the optical side of things, what's that?
Yeah, it's more. It's not have the RIIA, but it is an equalizer nonetheless.
Yeah.
Yeah, so it fits the cartridges, and it's a little bit difficult to work with the DS because they work with a voltage offset of 9 volts or 10 volts or whatever you put into them. And that means that typically phono stages or equalizers made for that have got a capacitor in the input.
Okay.
But we learned from tube circuits. So we made a circuit that can accept a raised voltage input with a JFET input. So we have made a long tail pair there that is floating in the input. So we just load the backside with the same voltage. And that means that we can create something without offset going out. And that is a fabulous way because then we omit and avoid the capacitors, which is always a filter in the signal path. So we have something that is extremely clear and bright and dynamic and whatever.
But you guys are very famous for doing digital products, and you don't do a turntable using, what is it, turnout?
Yeah, we use a tone-out turntable here. We have borrowed, so we don't have any turntable in our.
I thought it was a very interesting movement to
lineup.
go into the analog side of things, even though it's got a little bit of the digital thing in there.
I think for me the challenge, and for my team with Mikkel in the lead role in the designing these things, the challenge is always to create something very, very low noise. So everything we learn from making phono stages we can use everywhere in our electronics, and it is a king of difficulty to make a phono stage.
Okay.
Yeah. So when we look at our MC, where we have this enormous gain of 75 dBs, that's a lot of gain.
It's a lot, yeah.
So any noise you get into the start of that will be amplified a lot. So it's very difficult to get something that's completely free of hum or hiss or whatever. And if you take JFETs, their barrier, the barrier you can get is maybe 80, 82, 80 something dB of signal to noise ratio when you use JFETs. We use bipolar transistors. And that poses a whole shitload of other problems. But you can get bipolar transistors that has the same noise figure as a 3 ohm resistor, which is not a lot.
Okay.
So they are very, very quiet. If you use that in the input, you can make a phono stage that's extremely quiet in the 90s of dB at 1 kilohertz. So you can make something that is extraordinarily quiet. You just have to avoid current running out the bases.
Okay.
Because that will fry your cartridge. So there's a difficulty level working with bipolar transistors in the inputs of a phono stage.
So I'm going to ask the question: have you got any intention of making a turntable in the future, or is that?
Of course we have.
Okay. I thought you might have.
but I have had the ability and the desire and the wish for doing that for 10 years. It's not that yet there, so I don't know if we'll be 10 years from now or whatever it will be, but there will be a turntable one day.
So out of interest, you've said you've got the M2s at home.
Yeah.
What do you play, mostly digital or mostly vinyl at home?
It's a little bit of a mixture, yeah. I have a very nice cartridge on but I have a turntable. For me, it's sort of like a mix between what I have access to and performance. Okay. So I have a very modest turntable, but still it shines. It really, really works well.
Okay.
Yeah.
Okay, we're going to move on to the next room and we're going to talk about some other products from Audio Group Denmark. So we're here with Audio Group Denmark again. You've got several rooms here. We've just been in the very high-end room. We're now in the intermediate room.
Yeah, you can say that.
And we've got a few products to talk about here, but the first product we're going to talk about is the BBM.
Yeah, the BBM.
The Børresen bass module.
Yeah.
Are you going to keep calling it that?
I think so. For me, working with 2-channel primary, it's always been a bitch to find subwoofers that works with that.
Okay.
And the fact is that most subwoofers are made with a DSP.
Okay.
That introduces a lot of delay, so it's almost impossible to get a timing.
So have you removed DSP?
Yeah,
or?
we have removed the DSP. We do an analog filter instead.
Okay.
And that has not delays in it, so there's no timing issues.
So it's a bit of a departure for you to do a bass module. And
yeah.
Where did the idea come from?
Yeah, I think that the idea, of course, there's a commercial idea behind it, but I used to, in my university days, late 80s, think about that.
A long time ago.
A long time ago. I did speakers, apogee type, ribbon,
okay.
big door size, ribbon planar speakers.
Wow.
And I really loved the way they did the bass. And it was not until very late that I found out why this type of bass. You have this enormous energy, but it's like floating in space. It's not ever create congestion in a room. Okay. It really is a nice, airy type of bass, very precise, very transient fast, and you can say it's because it's sort of short circuit itself.
Okay. In what way short circuit itself? Yeah,
because it's an open baffle thing.
Okay.
So these bass modules are also open baffle, okay, but folded. And when you do something folded like that, you expose the backside of the driver to the front of the driver.
So is that to negate room interaction? Or?
Yeah, it has. What happens if you look at normal instruments? If you look at the kick drum, you have, the barrel, mm-hmm, you have the skin, mm-hmm, and you have the hammer, or the kick, and you hit it, and it shoots out the air. But there's no backside to it, so it doesn't really create pressure. Okay. It just creates this transient and air motion. Okay. So these are created like an air motion transformer. Basically, you push air together, it shoots out the front. And
so is that for speed and?
Yeah, you can make something use lightweight membranes. You don't have to use a lot of power. It's very transient friendly. So it's a very fast transient bass. But the primary thing happens is that you have no pressure
from the back to the front because it will cancel itself. So if you take a line going right through that, that's a zero pressure zone. That means that all that standing waves you get so much of in a normal subwoofer is gone away. Yeah. And it's placed like this on the in a curvature with the speaker. It also takes away room interaction issues from your speaker as well at the same time. Okay. And so it really cleans up everything in the room.
Okay. And are the Børresen bass modules powered? Are they?
Yeah, there's a 300 watt Class D amplifier.
Class D amp, yeah.
Yeah.
And primarily for, and I'm going to say this, we don't chase reviews at HiFi PiG. I haven't chased a review in absolutely years, but the pair of speakers that you see behind Michael, I am absolutely dying to review them. They got launched, and I just went, I've really got to review these. Yeah. But are the BBMs made specifically for these?
No, or? They are made for general use. Okay. We have used them for the M2s in our house.
Oh, wow.
We have used them for the M6s in our house. And what happens when you add that extra transient-friendly deep bass, you get an enormous texture. Not only you get more bass, but you get almost solidity added to every instrument, to voices, so you get a huge improvement of tonal color as well. It's an amazing.
So a little like an AMT or a ribbon tweeter brings to the top end, this is bringing to the bottom end, would you say?
Yeah, it is. It brings speed and clarity and cleanness and power. It creates a lot of
Which
power.
is what you want in the bass.
It's what you want. It's what you want. Yeah.
Okay, so we're going to move on from the BBM. We're going to talk about 2 new products as well.
Yeah, we have two new products more in this room.
So we're going to do a little bit of a jig about, and then we'll be straight back to you. So we've had a little bit of a jig about. We've talked about the bass modules, the Børresen bass modules. We're now going to talk about a streamer in the intermediate section of Audio Group Denmark's offerings. It's the SD288 streamer.
Yeah. Streamer DAC.
Streamer and a DAC all in one. So really, I'm just going to let you tell the viewers what it's all about.
Yeah, I think that for us it's new to blend the 2 products together, the streamer and the DAC.
Is this the first?
Yeah. No, we started that with the SD880. So this is a little sister to that.
Okay.
But the advantage is that if you look at streaming, you need a robust format to stream.
Okay.
So the package data, the PCM, the flags, are very robust because you have the option, like with the old CD players, to have error correction. So you can get a data package and check, is this correct? Mm-hmm. If it's not correct, you can reread it. So you have an option of making sure that your stream data is what you want.
And this is all done on the fly?
Yeah, it's of course all done on the fly, but so these formats that you get from Tidal or from Cubus or from Spotify or wherever you get the data from in the streaming, these package data are really, really robust. But they're shit when it comes to, they are really shit when it comes to D2A conversion.
Okay.
Because they are intended for ladder DACs.
Okay.
And a ladder DAC is where you open and close a MOS switch and put in a resistor, or don't put in the resistor, whether it's open or closed. And that creates a signal. You put a current of a certain magnitude, you get a voltage out, depending on what resistors are on and off. That's how ladder DACs work, essentially. And the format is written for that. And all the early CD players were doing it that way. Yeah. And a lot of high-end companies are doing
still
it
using ladder DACs, yeah.
Still using ladder DACs.
So what's
but they are the reason they are shit is because any switching has an overshoot, and every switching has a rise time. So whenever you switch something right in the signal path, you are bound to get some noise residuals. Yeah. No matter if you switch them 44,000 times a second or 88,000 times a second or 700,000 times a second, you get residual noise. And so you have to get that out, and that's difficult.
We were just in the other room, and earlier on we talked about noise, and noise is your enemy.
Noise is always the enemy because that takes the blackness away. So what we do here and what we do in the R880 is that we take the package data, put it into I2 square, and then convert that into DSD 512.
Okay.
And DSD is no longer a package data, it's a data stream. So we monitor that and take the average over a certain amount of samples. And that's a completely analog way, so there's no switching.
Okay.
There's just a continuous change of signal magnitude.
And
so it becomes analog in the way it's the D to A conversion is done.
Okay. So what is the DAC in there? Is it a...
Yeah, there's no DAC.
There's
no DAC.
Okay.
There's simply no DAC. There's a low-pass filtering of the DSD format.
Okay.
A DSD is sort of like a radio wave already containing the music signal.
Okay. So very analog in its form.
It becomes analog in its form. And it's, for me, DSD is a revelation in terms of the D to A conversion. But the problem is you cannot stream DSD because that is a direct data stream. And any error you have in the data transmission, the streaming, will go into the music. That's why you need the robustness of the data packages.
Okay.
So here you get both of those things. You get the robustness from the data packaging, and you get the analog way of doing the D to A conversion from the DSD.
So who's been involved with the development of this? Is this just you?
No, we have a team. We have a team. We have actually, there's 4, an R&D team around the electronics.
Okay.
Yeah. And Michael, who's also running around here, is a primary person for sure with the digital things.
So what do you think this, apart from being ultra quiet, what else do you think this brings to the table as opposed to other streamers?
It's a digital out of digital.
Okay.
It simply does. And we have to be very pleased that Sony and Philips did the CD. Because if they hadn't done the CD, there would be no music.
Yeah.
Yeah, because analog tapes cannot live
Forever,
since the 70s forever.
And
so
you
would just have a decline and a decline and a decline. And it seems, at least to me, that the opposite process, the A to D, is very robust.
Okay.
And I think it's because that's not a physical thing. That's just sort of monitoring. Oh, we have this level. Now we have this level. Let's write it down.
Okay.
So that's the A to D process is so much more, so less intrusive than the opposite process where you have to put something electrical or something physical to a number.
Okay.
Essentially.
So the next product we're going to talk about is
This one.
another phono stage.
Another phono stage, yeah.
So where this sits in between the phono stage we've just seen there.
Yeah, the phono stage we just saw in there is 70,000 euro machine. This is a 15,000.
Oh, okay.
So this is
So
a
does
totally.
it still have the 4 inputs?
No,
or?
this one has 2.
Okay.
Because, as you said, who uses MM anymore?
Yeah.
I told you a little bit about a London Decca is an
Of
MM.
course,
There's many good MMs out there, but this one does not allow that. But it has one MC input, fully adjustable, again from 50 ohm to 10 kilo ohm, and it in the loading, and it has also 3 different gain levels, so you can go from 58 to 75 dB gain.
And it has the optical thing as well, yeah?
It has the optical thing as well,
Which
yeah.
obviously we can see.
Yeah.
Yeah.
So I find that the optical cartridges is sort of a new take on converting motion into electricity. For me, that is
It's revolutionary, isn't it?
in terms of noise, yes.
Yeah.
In terms of noise, yes. But it also faces, issues with when you have a cartridge and a needle and you vibrate some beryllium foils. There can be some resonances, some shaking in there. So I think that if you see the first one, Aki brought out,
Yeah.
and to the ones you have today, everything has refined and improved so much, but it has a solid 0.75 millivolt output. So it's a really strong output compared to a really low output MC.
I remember speaking to Aki when he launched the first optical cartridge, and he said it's not perfect yet.
No.
And it's getting better, and it's getting better, it's getting better.
But when you see where he comes from, the optical knowledge that goes into every single mouse that you use on your table
Yeah.
comes from that family. So in essence, they also know that when you have a concept, you need to start working with the concept. And you can bring out something, but already when you finish the first product, you already know what to make better in the next generation.
Okay, so this is mid-tier stuff for you guys,
Yeah, this is mid-tier stuff for us.
Cool. So you're using, what are you using there? An LP12?
Yeah.
Oh, wow.
Lars, my business partner Lars,
yeah,
used
of
to
course,
have a hi-fi shop, and he sold a lot of these. So getting him that is like getting the kid his own toy, his own old toy again. But we use it with the DS Audio.
Yeah, that's sort of the old school and the very new school sort of
made together.
meshed together.
Yeah, but I understand Lars's fascination with the LP12 because it still brings so much joy to the performance. It's unbelievable. Where I see a lot of the HiMa's high-end turntable, they are maybe more precise and have a little bit better resolution, but they get boring.
Yep.
So I'd rather live with no perfection, but not boring. So if you understand.
Imperfections bring beauty to music, I always think.
Yeah, also with people, you know?
Yeah, absolutely.
If somebody is always correct, you
get bored of them very quickly.
What am I supposed to do? you know in a sense.
Fleming has just walked into the room.
Yeah, Fleming just walked into the room.
Has Fleming had input into different products around the range?
Fleming has a lot of inputs, always.
Yeah.
Always. And here, if you take the R880 we talked about in the other room, Fleming was very much involved in getting the boxes, then the design and the character of that. And a lot of those elements we took together and transformed into this.
I think from a design perspective, Fleming's got, the people have an eye.
Yeah.
He's got that eye for industrial design.
The beauty of our corporation is basically that he's an artist. I'm a stupid engineer. so in essence, every time he challenges me, can we do this, can we do this? I said, not necessarily, but he puts in some seeds here and there and here and there and here and there. So he brings a lot of inputs to the visuals of our things.
And I think that's very important, isn't it? I think the days of being able to put a black box out there and just go, right, it might sound great, but people don't want that in their homes. They want something that is aesthetically beautiful and functional.
Yeah.
So any desires for Audio Group Denmark to go down the one box route, or is that something for the future perhaps?
For speakers?
No, for a DAC, a streamer, everything.
Yeah, but
if
you take this one or the one behind you, which is an integrated amplifier, we have that in a U version as well, where streaming is built in.
Okay, so that's basically a one-box system.
That is a one-box system, like we have in the Access is also a one-box system. Okay. The only thing that's not in that is the analog.
Okay.
And I don't think it's really feasible in high quality to put analog in, because you cannot really go with discrete. You need to work with op amps, and once you work with op amps, you take the quality down.
And bring noise?
Yeah, essentially, because you have to, if you want to make a compact phono stage with op amps, you have to settle for JFET inputs.
Okay.
And when you settle for JFET inputs, you have the popcorn noise from them, and you also have they create noise by themselves, the way the junction works. The junction transistors are noisy. And you can, if you go discrete, you can parallel a lot. So if you have the best discrete JFET-based phono stages, have a lot of parallel JFETs in the input in order to keep the noise down.
Okay.
Yeah.
So we've looked at the BBM, we've looked at the new phono stage, we've looked at the new streamer. What else have you brought? I know what you brought, and we're going to have a play with them at some point.
Yeah, we brought a fully upgrade to some of our accessories.
Okay.
So the Sparks, the Darks, and the Swords are all in Generation 3. So
I'll be absolutely honest with you.
Yeah.
When I first came across the toys, as you called them earlier, I went, no, absolutely ridiculous.
Yeah.
And then I sat down and listened to them and just went, it's voodoo.
No, it's not. It's definitely no, but realize that every time you take a metal frame on an amplifier, put a connector on the back, what that is a perfect antenna. Yeah.
Yeah,
So
yeah,
you
yeah.
have an antenna there sticking out, and there has never been so much radio frequency noise in our room that there is today.
As I say,
Yeah.
I sat in front of them and,
Yeah.
and played with them and
Yeah.
went, it's not voodoo, there's something there.
Yeah, yeah, yeah.
They work.
Yeah, but we add our noise killing resonators, our Tesla coil technology. We add to every single antenna you have on an amplifier, and every time you reduce noise one place, you reduce it everywhere.
Okay.
So it is just there's nothing voodoo about it. It's just a tedious way of doing it.
Okay.
And the inspiration for this came, I used to work in a maritime communication, and there they have the antenna tuners. And for the VHF radios, it was paramount that they could listen as deeply as possible into the gravel of the noise or the noise floor. The deeper you could listen in, the earlier warning you could get if something was wrong.
Okay.
But you could also, with our VHF radios, where you could make weird channels that were not really in the schedule, you could listen into other people's weird channels. So you could listen to the fishermen saying that this is really good, this area, so let's go there. So the fishermen really relied on having good radios, also radios where they could make their own private channels so they can talk together without anybody listening.
Okay.
So the quality of a VHF radio is how deep can it listen into the noise floor. And this technology to get the carrier and take the sidebands away, that technology is actually quenching the unwanted part of the signal.
Okay.
And this is what we do here, is we quench by using a set of coils and inverse coils to take out the high frequency.
And you guys use a lot of coils in your products.
Yeah, we use these Tesla coils.
The Tesla coils were
Yeah,
very interesting. And when I first, years ago, I reviewed one of your products, and it talked about how many Tesla coils you got in there in each product, and the higher up the range you went, you got more coils.
More.
And again, I thought, no, this is just not right. And then I listened to it and went, yeah, there's something in this.
Yeah, but it is. If you take one of our power distributors where we also use this, and if you take a probe and have a noise generator, and you put noise in and put that into your IAC outlet, and you take one of the outlets and listen to what's on there, you will see if you put a 200 kilohertz square wave in on one side, it comes out rounded on the other side of it. So it takes that high frequency noise that you get out from your mains, the transients, turning on a washing machine or whatever, it takes those away, round them off, and when they round them off, they get into a frequency roam where the power supply can handle the rest.
I think one of the most interesting products of yours that I've ever sat in front of, it was the switch.
Yeah.
And we were in your factory, and I turned to Lynn and went, this is just bullshit. This cannot work. I didn't like to work. I turned and said, this is bullshit. And then you played music with it in the system, with it out the system, and then back in the system. I turned to Lynn and said, can I buy one?
Yeah.
And she just immediately went, yes.
Yeah, the thing is that you can send a spreadsheet to China and get it back. It's the same numbers.
Yes.
So there's no problem with the data. But what's the problem is the ground side is floating on the internet.
Okay.
So you attach yourself to something floating. That means that every single bit of wire in that internet is basically an antenna, and the ground pick up all that noise. So when we use the Tesla coil technology and create a virtual ground where we ground all this noise to, you get a much more noise-free environment. So while the data is the same, the associated connections are noisy, and you bring that into your system. So if you bring less noise into your system, whether it's on the ground side or on the signal side, you just get less. Noise doesn't care whether it's on the ground or if it's, if it's on the signal, it's noise is just, you always have the reference as the ground, but if the ground is noisy, then everything is noisy.
Yeah. Okay, so that's this year at Munich High End for us speaking to Michael and Audio Group Denmark. You guys are going to be at the Vienna show, yeah?
Yeah. We are
looking forward to it?
Of course.
Yeah, it's going to be great.
Yeah.
Thank you so much.
I think, in a way, was a BMW that bought this or have this or
I
own
believe
it or
so, yeah.
whatever, and are going to use it for themselves. So it's a little bit of a shame that it gets pushed out here, but a new venue, of course, it will be.
Have you been to the new venue?
No, I have not been there, but we had people down there looking at it. And
It's a very cool venue.
It's a very cool venue,
really
so
cool
I really,
venue.
really look forward to that.
So we'll see you there next year.
Absolutely.
Thank you so much.
You're welcome.